Okay. Question. Nasıl birleştiriyor onu anlamadım. No, I just wrote. So we had the matrix A above, and then we say we applied epsilon1 operation, and then the epsilon2, and then epsilon3. We get the matrix P, right? Is there a question for this? I guess not. Now, okay, good. Now then we had this lemma last time that if you apply epsilon to a matrix, let's say A, it's the same thing as epsilon times identity times A, right? Good. Now, from here, this is B is equal to, this is epsilon3, epsilon2, epsilon1 times identity. Now, this is epsilon, you apply epsilon3, and then if this is later, of course. Epsilon1 times identity is epsilon, I is, remember, this guy, this matrix. And then you apply epsilon2, and then you apply epsilon3. Now, this is a new matrix. Doing this operation epsilon2 means, that means epsilon2 times identity times this matrix. So you have a matrix, you apply the operation 3 by this property that we wrote at the end of last lecture, this one. So this was epsilon A. Epsilon A is equal to epsilon. Instead of applying a row operation to a matrix, it's the same thing as multiplying that matrix by another matrix. Namely, let me repeat again. So instead of saying that you apply the operation epsilon to A, that means, so either you can do this way, or you can apply this operation to the identity matrix and then multiply it by A. Of course, their sizes must be the same in order to be able to multiply this two matrices. And similarly, so we have a matrix, and then we apply this operation epsilon3. That means epsilon3 times identity times epsilon2 identity times epsilon1 identity. This is A. And above, I said this is E3, this is E2, and then this matrix is E1 times identity. So that means, let me write once again. So B is the matrix 1, 0, 5 over 7, 0, 1, 1 over 7. I hope this is something, it was something like this. And then epsilon3. What was epsilon3? 1 minus 2, 0, 1. So E3. E2 is 0, so 1, 0, 0, 1 over 7. E1 is 1, 0, 2, 1, and A is A. Let me write A. A is, what was A? 1, 2, 1, minus 2, 3, minus 1. Was minus 2 or plus 2? Minus 2. So now what do we have? So you have this matrix A, you multiply by E1, and then multiply by E2, and then multiply by E3, then you get this row reduced echelon matrix. Okay? So as you may ask once again, why do we find this echelon matrix? We will use it to solve the systems of linear equations as above. Okay, let's concentrate on finding the echelon matrix. Okay, so this is what we write here is in this row is in general. So here is that we may write this a theorem like this. So let A be a matrix, A be two matrices such that B is equal to first you apply some operation to A, some operation. It doesn't matter which operation is that. Then you apply this another operation, and then you apply another operation, and then you apply another operation like this. K operations. This is the same thing as. Then yeah. Then let me write like this. Then we may write this as B as epsilon k times identity, and then epsilon 3 times identity, epsilon 2 times identity, epsilon 1 times identity, and then matrix A. So this is these are elementary matrices. Elementary matrix is, remember, is the matrix obtained from the identity by a single row operation. So these are the matrices obtained from the identity by a single row operations. Elementary matrices. So if you call this matrix P, so we may write B as P times identity, where this B is any matrix. Okay, so, and P is a product of elementary matrices. Product of elementary matrices. Okay, so let me give another example. Okay, so here's an example. Here's an example. Let A is 2, 1, 3, minus 1, 3, 0. So the question is, you write this A, right? Multiply A by elementary matrices such that let's say EK E1 such that this product EK E1 times A is row reduced echelon matrix. So we have this matrix A. What do we do? How do we do this? We have this matrix A. Well, before this, let me write this idea first. Before this, so suppose we write this R. This is row reduced. R is row reduced, and then we applied. Suppose this is epsilon k. So you apply epsilon 1, some operation epsilon 1 to A, some operation. It doesn't matter what that is. We will see in a moment. And then epsilon 2, etc. These operations. Remember, this is epsilon k times identity, epsilon k, and then epsilon 2i. This is epsilon 1i times A. It's the same thing. Now, let's find these matrices. Let's find these matrices. So A is, so 2, 1, 3, minus 1, 3, 0. So I want to get this matrix into a row reduced echelon form, but at the same time, together with this matrix, I will apply this to the identity matrix 0, 0, 1. So first operation is let's interchange, in order to make this life easier, let's interchange row 1 and row 2. Row 1 and row 2, so that it is minus 1, 3, 0, 0, 1, 2, 1, 3, and then 1, 0. So that our first, this matrix, let's say E1, E2, etc., etc. So first E1 is this matrix. You apply a single row operation to the identity matrix. This row operation is, you interchange the first and second rows. This is epsilon 1. Now, next, from here, let's multiply the first row by minus 2 and add it to the second row so that this entry will be 0. That's why I do it. So as I said earlier, and it's also clear that earlier, I mean last time, the order, so you may have different row operations. Questions? So in order to make this 2, 0, you multiply the first row by 2 and add it to the second row. Then you have minus 1, 3, 0, 0, 1. You multiply by 2 and add it here, add it to second row. When you multiply by 2 and add to 1 is 7, 3, and 1 multiplied by 2, 2. So epsilon 2 is, you multiply the first row of the identity matrix by 2 and add the second row. This is the second. So I do two things together. I turn this matrix into a row reduced echelon matrix, and in the second entry, I will write this, the product of all these matrices, E1, E2, EK, the product of elementary matrices, which will be P in the above notation. And I will also find this each elementary matrix. I will also find each elementary matrix. Now, let's do it this way. And so we can now make this first row, this guy plus 1, so that minus R1.
Hocam.
So 1. Efendim?
E2'de yazarken 2, 1 yazdınız ama 1, 2 olacak, isterseniz arkadaşlar için düzeltin.
Why?
Çünkü 1, 2 olacaktı ama 1, 0 olarak geçirdiniz. Ay pardon, 2, 1 olarak geçirdiniz.
Let's see. So from here to, from this entry to the here, we multiply the first row by 2. And
yok, orası doğru.
Row, right?
Yan tarafa, sağ tarafa yazarken yanlış geçti sadece.
Well, let's see. We have this identity matrix, right? Right, we have this identity matrix. If you multiply, I did not write this. If you multiply the first row by 2 and add it to second row, you get this E2.
Pardon hocam, arkadaşlar tamam, doğru olduğunu söyledi.
Okay, good.
Pardon.
Good. Now multiply the first row by -1. It's 1, -3, 0, 0, -1, 0, 7, 3, 1, 2. So what did I do? Epsilon 3 is, so you multiply this, you have this identity matrix, you multiply the first row by -1. So -1, 0, 0, 1. This is epsilon 3. Next, I want to make this entry 1. So 1/7 R2. If you divide the second row by 1/2, which multiplied by 1/7, we have 1, -3, 0, 0, -1, 0, 1, 3/7, 1/7, 2/7. And this E4 would be, you multiply the second row by 1/7. So 1, sorry, this is 1, 1, 0, 0, 1/7. Okay, this is, remember, epsilon 4 times identity. Epsilon 4 is this one. Next, let's make this entry 0. So in order to make that entry 0, we should multiply the second row by 3 and edit the first row. So 3 times row 2 plus row 1. And edit to row 1, of course. So the second row stays the same, always. In the first row, we have 0 times 3 times 0 plus 1, which is 1. 3 times 1 minus 3 is 0. So that was our purpose. And if you multiply this by 3 and add it, is 9/7. 9/7. Multiply 3 by 3 and add it to 0. Multiply this guy by 3, add to -1. What is it? When you add it to minus, this is +1. Sorry, this is +1. Here it is -1. No, oops, confused. Is it +1 or -1? -1. -1. Okay, -1. Anyway, the sign mistakes are not so much important, and it's algebra is. So you multiply this by 3 and add the first row. This is -1/7, right?
Yes.
So that epsilon E5 is, you multiply, if you multiply this operation to the identity matrix, it is 3, sorry, not 3. So you multiply the row 1, row 2 by 3 and add it to the first row, you have this one. Okay, so therefore, if you say this matrix R, this is row reduced, this matrix P, so R is equal to P times the matrix A. What's P? P is these matrices E5, which is E5, E4, and E1 times A. E5 is 1, 3, 0, 1, and 1, 0, 0, 1/7, minus 1, 0, 0, 1, 1, 2, 0, 1, like this. And finally, 0, 1, 1, 0 times identity A, times A. So you can check that. the product of these matrices times A is equal to R. So let me remind you guys, all these your conversations also recorded. It can be seen on the it is seen on the side. Okay, on screen. Any questions so far? The important of this R is row reduced echelon form matrix. Okay?
Hocam ben bir şey sorabilir miyim?
Sure.
Bu matrixleri bulmamız için hani E'leri falan buluyoruz ya. Onları
Evet.
sadece row reduce echelon için mi yapabiliyoruz?
Ya, başka yerde de gerekli olacak sonra.
Ha öyle
Gene
mi? Tamam.
olacak. Tabii.
Tamam. Teşekkürler hocam.
It's very useful. So the idea is that you have a matrix. You want to write this matrix in a simpler way, just like in this. I wrote here. We wrote here R is equal to P times A, right? So you have the matrix A. You multiply it by a matrix P, which will be an important. It will be a. This P is a special matrix, which will be invertible matrix, and the result is a simpler matrix. So A is complicated, but R will be simpler. So when you have a system of equations, right? So you change that system to a simpler system so that their solutions are the same, and then you solve the simpler one. I gave an example at the beginning of the lecture. Okay. Okay, let's see. Okay, I don't. So let me. I have this example, but another example. But let me. I will not. What is too long? It's 3x4 matrix. Let me give this to you as an exercise. So let R is equal to, so A is equal to -1, 1, -1, 3, 3, 1, -1, -1, 2, -1, -1, sorry, -2, -1. Find the product of elementary matrices. Find the product E, let's say, of elementary such that this E times A is R is row reduced. Let me give you just start at the solution, and then I will leave this the rest to you. So you should write as above. We have this matrix A, -1, 1, -1, 3, 3, 1, -1, -1, 2, -1, -2, -1. So when we change this matrix by elementary row operations, let's see how the identity matrix changes. So for example, if you multiply first row by 3, so in order to make that entry 0, or first minus R1. Minus R1 is 1, -1, 1, oops, maybe I should write here. 1 minus 1, 1 minus 3, minus 1, 0, 0. The rest is the same. And then you make that entry 0. You should in each step you should do a single row operation. Okay, just a single row operation. Let me do it once again. So from here, 3 times row 1, sorry, minus 3 times row 1 plus row 2. So 1 minus first row stays the same. Last row stays the same, and that middle row you multiply it by minus 3 and add here 0, minus 3 plus 1 is 2, minus 3 minus 1 is minus 4, minus 3 plus 9 plus 8, and minus 3 is 3, 1, 0, and etc. So at the end, when you turn this matrix into the row reduced form, it will be something like this, and then you will have some entries, and here you have some matrix. So that matrix will be A. So in this case, this is, so when you have these zeros here, I guess it will be in that form. Yes, it will be in this form, something like this. When you write this way, then if you call this matrix A, then this matrix E times A will be row reduced matrix, will be the matrix equivalent to A. So namely row equivalent. Okay. So you have A when you multiply by elementary matrices. This is E is a product of elementary matrices. And the result is row reduced echelon matrix, something like that. I will leave this to you because it takes a little bit long, it takes some time. I did it, but I urge you to do it. Okay, and let's stop here for now, and then let's give 10-minute break.